All right, check out what we've built so far. Product carousel is working, language switching, done. Currency conversion, all set. And now we're going to continue working on homepage. Here's the Figma mockup. See this tag carousel? That's what we're building first. Click a tag, products filter instantly. No page reload, pure React magic. All right, let me show you how we're going to build this step by step. Firstly, since we're using feature slice design architecture, so let's create a new entity called tag. Inside, we need the model layer, then types folder, and a tag TS file. This is where we define our tag types. All right, let's export our tag interface. We need 3 essential fields here. id as a string for unique identification, name for display purposes, and slug for URL-friendly routing. Now let's scaffold out the UI layer, creating a UI folder, dropping in our tag list component, and of course, taglist.module, scss, because we're keeping our styles scoped and modular. All right, let's set up our component foundation. We're exporting taglist as a functional component that receives props, and now we need to define the types for those props. Now let's create our interface taglist props. We've got an optional tags array. Optional, because we might be loading data initially. Then is loading Boolean, so we can show skeleton states while fetching. The onTagChange callback is crucial. This fires whenever a user clicks a tag, passing the tag ID up to the parent component. And current tag ID lets us highlight which tag is currently selected. This setup gives us full control over the component's state from the outside, making it super reusable. All right, we're typing our props with taglist props right in the component signature. TypeScript autocomplete is going to love us for this. Now let's destructure everything. We're pulling out isLoading, current tag ID, onTagChange, and tags from props. This keeps our JSX clean and prevents that annoying props.repetition everywhere. Now for the JSX. We're returning a div with our tags class name as our main container. Then we import our styles from taglist.module, scss, keeping everything modular. Now here's the important part. We need to handle loading states first. Right before that container, we check if isLoading is true. If it is, we bail out early and return skeleton loaders instead. 4 skeleton divs to simulate our tag placeholders while data is fetching. Now we map through our tags array. For each tag, we check if it's selected by comparing its id with current tag ID. Then we render a button component. Notice we're setting the key prop to tag.id. That's crucial for React's reconciliation. Next, class name. We're using class name's utility to conditionally add the active class when a tag is selected. That's how we highlight it. On click, we call handle tag change, passing the tag id. Now let's write that handler. It's simple. We create handle tag change function that takes a tag ID and calls onTagChange with that id. The optional chaining here is key. If onTagChange isn't provided, nothing breaks. All right, time to set up our public API. We're creating an index.ts file in the entity root. This is our single entry point for everything tag related. We're exporting the tag interface so other parts of our app can type their tag data correctly, and we're exporting the tag list component so features can actually use it. This is FSD architecture in action. Now let's create our trending products widget. Here's a tip. We've already built best-selling products, and there's going to be a ton of overlap here. So instead of rewriting everything from scratch, we're just copying those files over to our new widget. Work smart, not hard. We'll modify what we need and keep the rest. All right, let's refactor the API. First up, renaming the endpoint to get trending product tags. Then we change the API instance name to Trending Products API. Export hook, updated. Now we're switching the URL to /tags/popular. Here's the key part. We're not fetching products anymore. We're fetching tags. so we change the return type to tag array. The interface name changes from that generic args to trending tag query, because this query is going to have multiple variations. And since tags don't need currency, we're removing that field from the interface. Clean up the unused imports. And finally, rename the file to TrendingProducts API. TS to match our API instance. Everything's consistent now. Now, let's move to the UI layer. First things first, renaming all the files to match our new Trending Products widget. Inside the component file, let's clean things up. First, remove that unused import. Keep it lean. Now we swap out the old query for the one we just created. Get trending product tags. But here's where it gets important. We need to rename our variables properly. We're going to have both products and tags in this widget, so we can't just use generic names like data or query totems. If we don't distinguish between them now, debugging later is going to be a nightmare. So let's be explicit. When we destructure from our query, we're calling it tags, not data. When we reference loading states, it's tags isFetching, not just isLoading. This might seem like overkill now, but when you're managing multiple data sources in one component, clear naming saves you hours of confusion. Trust me on this one. Now we need to track which tag is currently selected, so let's create a current tag ID state using useState. We're initializing it with an empty string because nothing's selected on first render. Notice I'm explicitly adding the generic type here, useState with string. Yeah, TypeScript would infer this automatically from the initial value, but being explicit makes our intent crystal clear and prevents accidental type widening if we ever change that initial value. Plus, when someone else reads this code, there's zero ambiguity about what this state should hold. Now let's drop our tags between the carousel header and the actual carousel. We're wrapping tag list in a container div. Might seem unnecessary now, but if we need to add spacing or layout adjustments later, we've got the flexibility. Now we pass in all the props. Tags from our query. IsLoading is set to tags isFetching so it shows skeletons while loading, current tag ID to highlight the active tag, and onTag change. When we get to onTag change, we need to create that handle tag change function. It takes the tag ID that was clicked and calls setCurrentTagID to update our state. Why not just pass setCurrentTagID directly? Because we might want to add analytics tracking, reset pagination, or trigger other side effects when tags change. Keeping it in a handler gives us that flexibility without refactoring later. Now we need a useEffect to handle the initial tag selection. Here's the logic. We check if tags exist, if the array has at least one tag, and if current tag ID is still empty. If all three conditions are true, we automatically select the first tag by setting current tag ID to tag0.id. Why do we need this? Because when the component mounts and tags load, we want to show products immediately, not an empty state. The dependencies are current tag ID and tags, so this runs when tags finish loading or when current tag ID changes. This ensures that as soon as we have data, there's always a selected tag, and products are displaying right away. All right, let's comment out everything related to products for now. We need to test our tags in isolation first. So we're commenting out the product's destructuring, the total count variable, that total display in the header, and the product carousel. Now let's actually use this widget on our page. But first, don't forget to update the public API exports in the widget's index file. Then we can import trending products and drop it onto the home page. And there we go. Tags are rendering on the page, which means our query is working perfectly. Now we just need to add some styles to make this actually look good. Let's style the tags container. We're setting it to flex with a line item center to keep everything vertically aligned. FlexWrap lets tags move to the next line if there's not enough space, responsive by default. And a 12px gap gives us nice breathing room between each tag. Now for the button styling. We're setting the theme dynamically. If the tag is selected, it gets outline, theme. Otherwise, it's tertiary. This gives us that visual feedback, showing which tag is currently active. Let me show you the result compared to the Figma mockup. And look at that. It's pretty much identical. Tags are styled correctly. Active state is working. Everything matches the design. Now we can clean up the button component. We're removing that class name's utility and the conditional active style, since our theme props already handle both states perfectly. No need for redundant styling. Now let's create our skeleton styles. We set height to 40px and width to 80px to match our actual tag buttons. The magic is in the background. We're using a linear gradient that goes from gray 200 to gray 100 and back to gray 200. This creates that shimmer effect. Background size is set to 400% by 100%, making the gradient way bigger than the element itself, which is crucial for the animation. Then we apply our shimmer animation, 1.2 seconds, ease and out timing, and infinite loop. Border radius of 20px matches our button styling. Now the keyframes. At 0%, we position the background at -200%, completely off to the left. By 100%, it's at 200%, completely off to the right. What this does is slide that gradient across the skeleton from left to right continuously, creating that polished loading shimmer you see in modern apps. It's a small detail, but it makes the loading state feel premium instead of static and boring. Now let's hardcode is loading to true instead of using the actual loading state. This lets us see our skeleton animation in action without having to refresh and catch that split-second loading moment. As you can see, the skeleton elements aren't positioned correctly. To fix this, we need to replace those empty fragment tags with the same container div we're using in the actual tag list, the one with our tags, class name, and flex styles. Now it looks way better, but let's add a few more skeleton elements to really simulate what the actual tag list would look like with more tags loaded. Alright, now let's make this component actually useful by adding product loading. Let's start where we always do, with the API query. Let's copy the old query and start modifying it for our needs. First things first, we're renaming it to get trending products by tag, way more descriptive of what this endpoint actually does. Now for the response type, we're changing it to product API response. We've worked with this type in previous videos, so it should feel familiar. It's got our products array, pagination info, all that good stuff. Now we need to create the interface for our query parameters, so let's copy over another interface and rename it to trending products by tag query args. This one's going to be specific. Besides locale, which we always need for translations, we're adding currency because product prices depend on it. And tag ID, that's the key one. It tells the backend which tag we're filtering by. Now take this type and pass it into the generic of our query definition, so TypeScript knows exactly what parameters this endpoint expects. Change the URL from /tags/popular to /products. We're hitting a different endpoint now. And last step, we need to export one more hook so components can actually consume this query. Add it to the exports. Now let's use this hook in our component. We already have one hook call here, so let's just copy that structure. Change the hook name to the one we just created. Get trending products by tag. Now we need to add the missing parameters, currency and tag ID. We've already got those variables prepared in our component, so just pass them in. Here's the critical part. We're using the skip option. This tells RTK query, don't make this request yet. About those. Why? Because if current tag ID is empty, we're sending a request with no tag filter, which either errors out or returns wrong data. Skip prevents that wasted network call. So we only fire this query when we actually have a tag ID selected. It's a small optimization, but it prevents unnecessary API hits and potential errors on initial render before tags have loaded. Now let's uncomment everything we commented out earlier. And we need to update all those variable names to match what we just defined. Products, is loading, error states, all of it needs to align with our new hook destructuring. Notice we're checking error for both products as error or tags as error. Why both? Because if either request fails, we need to show an error state. If tags fail to load, the whole component is broken. Users can't filter anything. If products fail, same problem. Empty carousel. So we handle both failure cases with one error prop, keeping the error handling clean and comprehensive. Everything's working perfectly, but let's add some margin to our tags container to give it proper spacing from the surrounding elements. And there you go. Everything's working beautifully. We've got the first tag selected by default. When we click a different tag, new data loads in. And here's the cool part. If we click a tag we've already selected before, the data is cached by RTK query, so there's no loading state, no network request. Instant response. That's the power of proper caching. All right, let's check the Figma mockup for what we're building next. This is the first order section. You can see it's got this promotional banner. This is a conversion-focused section, so we need to nail the visuals and make those numbers pop. We're creating a new folder inside pages/home/UI because this banner is only used on the home page. No need to make it a shared widget when it's page-specific. Keep the architecture clean. All right, let's build out the API query to fetch our discounted products for this section. Let's call this query getFirstOrderProducts and copy the structure from the neighboring query. We're changing the response type to just products array. We don't need the full product AP response here, since we're only getting the products, no pagination or extra metadata. Now let's create the params interface, FirstOrderProducts query args. We need locale for translations and currency for pricing. That's all we need for this one. Keep it simple. Change the URL to match our endpoint and export the hook so we can use it in the component. Now let's create the component. We grab the current language and currency from our app state and pass them straight into our query hook. Now for the JSX structure. We've got our main container first order section wrapping everything, and it's split into two major sections. First up is product cards. Here we're mapping through the products array we got from our API query. For each product, we render a product card component, and we're setting the key prop to product.id for React's reconciliation. This is our visual product showcase on the left side of the banner. Now the second section, the info panel. This is where all our promotional content lives. At the very top, we have the offer text, get 10% off F, and we're pulling it from our translation system using that FirstOrderSection.discount offer key. Below that is our main heading, the big Order Now Your Grocery text, also internationalized. Now here's the cool part, the stats section. We've got three separate stat items here. The first one displays 1K plus items. Notice we're using a counter component that animates from 0 to 1400, and we're passing format compact number as a formatter so it shows 1K plus instead of the full number. Way cleaner visually. The second stat shows 20 minutes, another counter component, but this one just counts to 20, no special formatting. Third stat is 30% up to offers, counter animates to 30, and we're using a custom formatter that adds the percent sign. Each of these stats has a title with the animated number and a description below it pulled from our translation keys. And finally, at the bottom, we've got our call to action button, size large to make it prominent. Inside it, we've got the Order Now text from translations and a chevron right icon to give it that forward motion, making it feel more clickable and action-oriented. Let's break down the styles. Starting with FirstOrderSection, we're using Flexbox to lay out our two main sections side by side. Gap of 64px gives us nice breathing room between the products and the info panel. Margin top 80px separates this from the section above it. Background is using our green 50 CSS variable to match that light green from the design. Padding of 40px all around gives content room to breathe, and border radius 24px gives us those smooth, rounded corners, modern and clean. For product cards, we're using flex again with a 24px gap between each product card. This keeps them aligned horizontally with consistent spacing. The info section gets margin 0 auto, which centers it within its flex container. This is important for the layout balance. Now, the offer text. We're setting color to our primary color variable. Font weight 600 makes it semi-bold so it stands out, and margin bottom 8px gives just a touch of space before the title. The title is using our font XL variable for that big, bold heading. Font weight 600 again for emphasis, and margin bottom 24px creates solid separation before the stats section. Stats container is flex with 32px gap between each stat item, keeping them evenly spaced horizontally. Margin bottom 24px pushes the button down. For stat item title, we're using font L variable. These numbers need to be prominent. Font weight 600 makes them bold, and margin bottom 4px tightly couples them with their descriptions below. Stat item description uses our base font size, smaller than the numbers, creating that visual hierarchy. And finally, the button styles, we're targeting the SVG inside it. Fill none and stroke white ensures our chevron icon shows up properly in white against the button's background. This is important because SVGs can inherit weird defaults, so we're being explicit about how that icon should render. We need to handle loading and error states properly, so let's create this render product cards function. First check is fetching. If data is loading, we return 3 product card skeleton components. Why 3? Because that's how many products we're planning to show, so the skeleton should match that layout. This gives users immediate visual feedback that content is coming. Second check is error. If the request failed, we show an error container with a translated error message and a retry button. Notice we're calling handle retry on click. This will refetch the data, giving users a way to recover from network failures without refreshing the whole page. Third check is for empty state. If products is null, undefined, or an empty array, we show a no products available message. This handles edge cases where the API returns successfully but with no data. And finally, if none of those conditions are true, meaning we have data and everything's good, we map through the products array and render a product card for each one, with the product.id as the key. This is the happy path, what users see when everything works perfectly. This pattern of handling loading, error, empty, and success states is crucial for production apps. You can't just assume the happy path. Real apps need to handle all these scenarios gracefully. Alright, let's build the counter component to animate those numbers. First, the props interface. We've got from, which defaults to 0, that's our starting number, to is required, that's our target number. Duration ems defaults to 2000 milliseconds, so 2 seconds for the animation. Formatter is optional. It's a function that lets us format the number however we want, like adding percent signs or making it compact. And once defaults to true. This controls whether the animation runs once or every time it enters the viewport. Now we destructure those props with their defaults. We've got 3 pieces of state. Cache, value starts at, from, this is the current number being displayed. Started, tracks whether we should begin animating. And ref is attached to our span element so we can observe it. First use effect sets up an intersection observer. This is the secret sauce. We're watching our element, and when it enters the viewport with at least 50% visibility, threshold 0.5, we set started to true, which kicks off the animation. If once is true, we disconnect the observer immediately so it only triggers one time. When the component unmounts, we clean up by disconnecting the observer. Second use effect is where the actual counting happens. It only runs when started becomes true. We're using request animation frame here instead of set interval because it's smoother. It syncs with the browser's repaint cycle. We track when the animation started with the start variable. In each frame, we calculate progress as a value between 0 and 1 based on how much time has elapsed. Then we interpolate between, from, and to using that progress. This gives us the smooth counting effect. We update the value state, and if we haven't reached 100% progress yet, we request another frame. When the component unmounts or dependencies change, we cancel any pending animation frame to avoid memory leaks. The counter is starting immediately because of our promo banners at the top of the page. We need to tweak the code so it only triggers when the first order section itself comes into view, not when any counter appears on screen. We also need to add compact number formatting. Let's create the format compact number function. We're using international number format with NGB, locale, setting notation to, compact, which automatically converts big numbers to readable format, and compact display to, short, so we get 1K instead of 1000. This makes those big numbers way more digestible. And let's finish off this page with the Categories Carousel section. Let's create a new entity for categories and set up the type definition for it. Creating the widget now. API layer, UI components, the whole setup just like we've done before. The only new thing here is this file. It's just a list of icons with their names and the icons themselves, just like we did with the currency in the previous videos. Thanks everyone for watching. In the next video, we'll be creating a modal like this one with a map, so make sure to subscribe and leave a like if you're interested.